Welcome back, everybody. Let's continue talking about correlations, but now let's focus on section 7.3, where we will discuss best fitting lines and making predictions based on our scatter plot and based on that best fitting line. You'll see what I mean in just a second. A regression line is a line that really comes as close to as many points as possible, and we use it to predict values. And we've been doing that kind of all along. We've been putting a line in there, trying to get a sense of the nature of the correlation. Well, which line provides the best fit? Because, of course, we're just kind of estimating when we've been drawing lines in there. Well, a least squares approach to finding this regression line really works best. And that can be found using a mathematical formula like this. And we're not going to do that. We're just going to eyeball the data. What the least squares approach does is it tries to minimize these squared errors. So we have some errors in that the data points are above the line, some errors in that the data points are below the line. You see the line isn't perfectly capturing all the data points. And this mathematical formula for the line will try to minimize these errors, these squared errors, because some of them are positive and some of them are negative. Bottom line is that's all just kind of the mathematical background for what I'm talking about with this least squares solution. We're not going to do that. We're just going to kind of eyeball it. We're going to do what we've been continuing to do because we're just trying to understand conceptually what's going on with these regression lines. So, for example, once we fit a regression line through the data, we can get a sense of approximately how much a 1.5 carat diamond is worth. Here we're looking at diamonds in terms of their weight in carats, and we're looking at their value in terms of dollars. So if we look right here at 1.5 carats, according to this regression line, we can see that they're worth approximately maybe $9,000, somewhere in there. And we can see a few data points. They're not completely fitting this regression line, but we can use that regression line to make a general prediction about a diamond's value. You'll see this a little bit more clearly once we go through a couple more examples. And again, this is just showing how it's kind of pairing up where these data points would fit according to that regression line. Well, there are some cautions that we need to keep in mind when doing that. Let's talk about them. Here's the same data that we were looking at before. Let's go through each of these cautions and make sure we understand what they're all about. First of all, weak correlations generally result in weak predictions, and that should make sense. Think about it this way. In this particular case, we see a relatively strong correlation here. Our data points are not perfectly corresponding to this trend line, this regression line, but they're pretty darn close. That's a strong correlation. This would be a correlation of 0.75. That's pretty darn strong. Well, if that's the situation, we can predict these prices based on the weights of the diamond pretty successfully. However, think about this situation. You can clearly see right here that the correlation coefficient that we would find is not going to be anywhere near as strong as the correlation coefficient that we find right over here. This looks almost more like that shotgun blast we were talking about, where there would be no correlation at all. Now it looks a little bit better than that. We can fit some type of trend line in here, but once we fit that trend line, we see that there are so many data points that are far away from that trend line. And in fact, in this case, the correlation coefficient would equal about 0.25. So that's much weaker than it is right here. And my point is simply this. If we are trying to predict the value of a diamond based on its weight using this data, because the correlation is so weak, look and see how many errors we essentially have in here. We're predicting that a diamond that weighs 1.5 carats is going to be worth somewhere around $9,000. That's our best prediction based on this data. But we can see when we actually look at the data points, some of them are right around 9,000 but less, but some of them are quite a bit more. The bottom line is our predictions aren't going to be nearly as solid when we have a weak correlation compared to when we have a strong correlation. Here's another point to think about. It's unwise to make predictions beyond our data. So for example, what's the price of a 10 carat diamond? Well, we only really collected data here regarding diamonds that weigh, like 2 carats and less. So if we're trying to predict the price, the value of a 10 carat diamond, that's going beyond our data. We don't really have data like that. Now, we can predict that this regression line will follow through all the way to 10 carats, but that might not be a safe bet. Let's just look at this for a second. At 1 carat, the price of a diamond was about $6,000. And those prices are sticking pretty close in there with all these diamonds that weigh about 1 carat. Let's look at diamonds that are about 2 carats. Again, 12,000 is a pretty decent prediction because we can see that diamonds that are in this weight class cost about that much. So we're talking about approximately $6,000 per carat. But now think about this. If we were to extend that out to a 10 carat diamond, then we might be estimating that it'd be worth about $60,000. And although that sounds like a lot of money, a 10 carat diamond is very rare, and it would probably be worth much more than that. My point is simply this. If the only data we have is regarding these types of diamonds that weigh these weights, we wouldn't expect that our predictions are going to be very accurate when we extend way beyond that data. Okay, so just keep that in mind. Past data might not predict future data very well. Here's another thing to keep in mind. We might have collected this data a couple years ago. Why do we think that it's going to predict the price of a diamond very well this year? Particularly because things change. We don't know what's going to happen to next year's prices of diamonds. And in fact, many people in the industry I've read have been predicting that prices will go down because people no longer think they're necessarily so important, in defining a relationship. You don't necessarily need a diamond ring, for example. Here's another thing we should think about. It's unwise to make predictions beyond your population. So clearly here we're dealing with diamond prices. We wouldn't want to use our regression line, our trend line, to try to make predictions about gold prices. That doesn't even make sense. So that's obviously a caution that's pretty easy to understand. And here's another point. Regression lines don't work well with data that's nonlinear. We already discussed that when we're computing correlations, we are trying to fit a line. We're trying to find a linear relationship between these data points. When we have data that is not linearly related, then a regression line is not going to work very well. So this would just be an example. Let's say that the relationship between the weight of diamonds and the value of diamonds had this type of relationship, and it's clearly not linear. Then if we were to fit a regression line through it, our predictions wouldn't work very well because we can see the value starts to increase quite quickly as we get past about 1.5 carats. So when we have nonlinear relationships, our regression lines that are built based upon linear relationships will not work well. All right, let's talk a little bit more about the data that we're dealing with. When we compute a correlation coefficient, R, we can learn something really important about the data in terms of the proportion of variation that variable is able to explain by being included in that regression line. So the more variation we can account for, the better that regression line predicts values. You'll see what I'm talking about in just a second. In this particular case, let's just assume, because it's true, that the correlation coefficient equals 0.75. If we were to take this R value and square it, we can find this proportion of variation in that variable that is explained by that regression line. In this case, if you take 0.75 and you square it, you'll find a value of 0.56. And this is how we interpret it. This is where it's going to make a little bit more sense for you. That would mean that about 56% of the variation in these diamond prices can be explained by the relationship between diamond prices and weight. In other words, about 56% of the variability in those diamond prices can be explained by its relationship with weight, the diamond's relationship with weight. Now, as that correlation coefficient gets smaller, you can see that the R squared value is going to get smaller as well. So let's look at another example here. If the correlation value was equal to 0.25, when we square that, r squared is just equal to 0.06. So we noticed before that when the correlation between the two variables is relatively weak, our prediction is going to be relatively weak. And here the amount of variation that we're able to explain is relatively small. So in this case, only about 6% of the variation in diamond prices can be explained by the relationship between diamond prices and weight. So only about 6% of the variability in those diamond prices can be explained by the weight of the diamond. So as the correlation goes down, as that value decreases, the amount of variation that we can explain by this linear relationship decreases. That should make basic sense. Here's an important point. Multiple regression tries to account for extra variation by including other predictor variables. So for example, we can put into an equation not only the weight of the diamond, but also some data for its clarity, for its color, things like that. And the more predictors that I have in that equation, the better I can then predict the value of the diamond. That's what multiple regression is all about. It's essentially computing correlations where we have more than one predictor variable. In this case, the one predictor variable that we have is weight. We're trying to understand the value based on the weight. We'll now just assume that we are trying to understand the value of the diamond based on the weight, based on the clarity, based on the color. So we have several different pieces of data all going into the equation to explain the price. That's probably going to result in a better prediction. That's what multiple regression is all about, and I just want you to be somewhat familiar with the term. No big deal. All right, everybody, that's it for section 7.3. For now, that is all.